So previously, we were studying the open optimization, which was actually referred to as the unconstrained optimization. So we were just thinking about how to find the x and y through first order conditions and through the second order conditions to ensure that the optimization that we do is a maximum or minimum, but there is no restriction imposed on this. Okay. So here, another extension of application of calculus is to figure out constraint optimization. So how do we add a constraint to it? So say if we have an objective function that is f of x and y, okay, and we have a constraint, then how do we optimize our function under the constraint? This is what we do. This is referred to as Lagrangian equation. So what we do is we construct a Lagrangian equation by setting L, standing for Lagrangian, equal to the objective function itself plus lambda multiplied by the constraint when it equals to 0. This may be a little bit abstract. It will be cleared up as I go over one example for you. So lambda is the Lagrangian multiplier, which is the change in the objective function for a unitary change in a constraint. I will demonstrate later what that is as well. So we're gonna first demonstrate how to solve by hand and then do this through Excel. Okay, so how do we solve by hand? First, we set up the correct Lagrangian equation as above mentioned, and we derive the first order conditions like we did in 5-1. So here we are going to have 3 first order conditions because both x, y, and lambda are considered variables. Okay, so we have a system equation, 3 equations for 3 unknowns, and we can solve for x star, y star, and lambda star. And the value of lambda star actually tells you how the function, the value of the function of your target will change if the constraint is loosened by 1 unit. If asked, we check the second order conditions to ensure you are maximizing it, but I will not ask this for this class. Okay, so now let's look at example 1. So here, example 1 is to ask you to maximize this function, okay, subject to this constraint. And now you have to figure out the value of x and y that solves the following optimization problem. Okay. So let's get to this.